So the question here is calculate the currents and voltages in the circuit given below full stop. Also calculate the power dissipated in the transistor full stop. The transistor parameters are beta is equal to 100, VBE on is equal to 0.7 volt and VCE saturation is equal to 0.2 volt. And this is the circuit given here. So this is the question they had asked for engineering services examination in mains paper for electronic and telecommunication from the subject of EDC for 10 marks. So here as per the question we need to find out the different type of currents here as well as voltages. So with respect to current, what we need to find out here, we need to find out their base current as a IB and their collector current here as a IC saturation. If it is verified that it is working into saturation, then we will find out this IC saturation. Otherwise, it is working into the active region. Apart from this, it has given here the values as a VBE on is equal to 0.7 volt. So this is here plus minus 0.7 volt. So this is the voltage between base to emitter terminal of this base to emitter junction of this transistor. And here it has given another value as a VCE saturation is equal to 0.2 volt. So this is here 0.2 volt. This is here 0.2 volt as a VCE saturation voltage. So if the transistor is working into saturation, it means this voltage VCE is equal to VC, or we can say that it is V output, and this is here as a 0.2 volt. Now here for this kind of questions, first of all we should know whether transistor is working into saturation region or not. So for that purpose it has given their beta values here. So first of all we need to find out this IB by solving this input side of this transistor, like by solving this part of the transistor or this loop of the transistor, we can easily find out their IB value. Then we need to calculate this IC saturation, and after then we need to find out the ratio of these two. So that is called here as a beta dash or beta forced value. So if this value is lesser than equal to the given beta here as a 100, then we can say that our assumption as a transistor is working into saturation will be correct. Otherwise it is working into active mode. Then we need to find out the parameters accordingly. So now here first of all we can find out their IB value here. So what will be their IB value? Their IB value will be, for this circuit, their IB is equal to 8 volt is their input voltage here, and the drop across base to emitter junction is 0.7. So 8 minus 0.7 divide by 220, and due to this kilo their order will become here as a milliampere. So if we solve this, we will get it here as a 0.033 milliampere. So this is having 0.033 milliampere. Now by assuming this transistor is working into saturation region, we can easily calculate this IC sat value here. So this IC saturation is equal to what? This is having the supply here as a 10 volt. So 10 minus the voltage drop across this collector to emitter is having 0.2 volt. So this is here 0.2 volt divided by 4, and due to this kilo their order will become as a current milliampere. So now here if we solve this, we will get it here 9.8 divided by 4 milliampere. So ultimately this will become here as a 2.45 milliampere. Now we need to find out the ratio of IC sat by IB, which is called here as a beta dash or beta forced. So if we'll find out this, we'll get it here IC saturation, this collector saturation current divided by IB. So this IC sat, we got it here 2.45 milliampere, and this IB is having 0.033 milliampere. So this milliampere gets cancelled, and we will get it here 73.83. 73.83 is giving the indication here this beta dash or beta forced is lesser than this given beta of 100. So this is giving the indication this condition is this value as a 73.83 as a beta dash is lesser than this beta as a given 100 is giving the condition here that whatever we had assumed that transistor is operating into saturation, it is verifying that whatever we had assumed our assumption is correct. So that is the reason it is working into saturation region with their output voltage or VC voltage or VCE, because this VCE is equal to VC minus VE. So this emitter is at ground, so that this VC, whatever this VCE is given 0.2 volt, this VC minus 0. So ultimately this collector voltage will become their output voltage as a 0.2 volt. So we got here as a VC value. Then from this side, by solving this input side, we got their IB value as a 0.033 milliampere, and then this we got it here as a IC sat is equal to 2.45 milliampere. So these all are their current whatever they had asked as per the question. This is IB value, this is here IC saturation value, and here by solving this we got the condition whatever we had assumed, it is justifying for that. And next part of the question they had asked about that power dissipated by the transistor or power dissipated in the transistor. So power dissipation by the transistor is given here, PT is equal to IC into VCE saturation, because the transistor is working into saturation region. So we need to multiply this IC saturation into VCE saturation to get their power dissipated by this transistor. So here this IC sat, whatever we got it here as a 2.45 milliampere into VCE sat, it has given 0.2 volt. So by solving this we got it here as a 0.49 milliwatt. So we got it here, the power dissipated by this transistor PT is equal to 0.49 milliwatt. So this is the another part of the question. So by this way we got here all this part. First one is like we got it here as a base current, then we got it here as a collector saturation current, after then we got that power dissipated by the transistor. And by this way this is the end of the explanation for this question.